So hi, my name is Meghna. I'm 17 from Orlando, and my talk today is going to be a little different. It's basically just to present to you all my research project that I've been conducting for like the past year. So just kind of introduce myself. This is me. So I started my cybersecurity journey in around 6th grade. I was watching my dad, because my dad also works in IT, and I was watching him click away on his computer all day. And I was like, what is this guy doing? Why can't he play with me? And I would sit with him and I'd wonder why, like, what is he doing? And he sat down and explained to me this wonderful new concept of artificial intelligence when I was only 10 years old. And this led me to start my very first science fair project. Back in 2019. It was called Artificially Intelligent or Intelligently Artificial. And all I did was I talked to Siri and I talked to Alexa and I called it a science fair project and I said it was AI. It was horrible. I didn't win anything. It was a pretty bad project, but it started my journey. And in 2021, about 2 years later, I actually won first place with another project called Identical Identity. And in that project, I basically used biometric authentication and AI for the first time because that was when we were right coming out of COVID. And everyone was wearing masks, but touchless authentication was becoming so huge. But if we were using Face ID for everything and then we had our faces covered, how was that supposed to work? And so for the first time, I was able to win first place, and I also got recognized by the US Navy later on in this project. And then this year, I continued my research and really went into cybersecurity, which is what I'll be presenting today. But I won first place at my regional science fair, qualified myself to states, won at states as well, placed in the top 3 in the entire state. I then went to the Lockheed Martin Science Challenge, won first place there as well, and this last week, I came back from the International Science and Engineering Fair held in LA, and among 62 countries, I was one of the top 50 in the world for software. So I have also presented at B-Sides SLC. This is my second B-Sides, and this is basically my project that I'll present today. So here's a little picture of me at LA. Those are my 3 best friends. That's the LA Convention Center, and that's me presenting to a bunch of middle schoolers. But to actually introduce, so in cybersecurity, I'm sure everyone's heard of security vulnerabilities. They're the root cause of data breaches, hacking, and things like that. And these vulnerabilities are the core reason why people lose money, people lose their identity, and just in general, they are the core reason why problems arise. And I wanted to see if I could partner generative artificial intelligence to help mitigate these vulnerabilities in a much more efficient way than what already exists. So currently there's this company called SemGrep, and they have a static analysis tool. And the static analysis tool basically, it goes through and it kind of looks through your code and it gives you a YAML file rule based off of a large repository that they have. So in this repository, they have a YAML rule that can tell a developer how to better their code for every single vulnerability that's known with an ID for every single language out there. So it's this wonderful resource, it's a wonderful database, but it's not being utilized in the way that it should be. And what I wanted to do is to see with SemGrep how I could make it better. And why I chose SemGrep is I did a little bit of research on other static analysis tools out there. There's SemGrep, there's Pylint, there's Flakegate, Bandit, and there's so many more. And I think Pylint and Flakegate, they're like linting tools, so they're not exactly looking into fundamental issues, they're looking more into just over-the-top issues. And so overall, I chose SemGrep as a static analysis tool to analyze in this study and how I could make it better using AI. So the goal of my research, as I said, was to partner external static analysis tools, especially SemGrep, with generative artificial intelligence to see how I could make it better. So the 5 vulnerabilities that I chose for this project specifically targeted JavaScript. And these are the 5 vulnerabilities that I chose. We have denial of service, eval injections, cross-site scripting, broken authentication, and SQL injections. And I'm sure at least one of these names rings a bell. And these 5 vulnerabilities, I did a little bit of research, and there was an OWASP top 10 list of vulnerabilities in JavaScript that really, really hurt a lot of developers on the daily, and that's why I chose these 5 vulnerabilities. And what I did with them is I wanted to use ChatGPT, because ChatGPT is a home name at this point. Everyone knows GPT, everyone knows what it does, whether you're cheating on homework or whether you're trying to get something fruitful done. Everyone knows GPT. And when you're using GPT or in general an LLM, you have to get an optimized output, but how do you get that? By optimizing your input. And so prompt engineering is a big part of that optimization, and specifically shot prompting is what I used for this project. So what I wanted to do is using shot prompting to explain what shot prompting is. It's basically For example, a zero-shot prompt is saying, hey, do this. A one-shot prompt is saying, hey, do this, here's some examples, or here is a example. 2 shots is 2 examples, 3 shots is 3 examples, so on and so forth. And so what I wanted to do is I wanted to use GPT and this partnering with shot prompting to actually structure out and make GPT create me a YAML rule mirroring what SumGrep is doing, but instead of doing it in that static way that SumGrep does, doing it in a more dynamic way. Because what SumGrep is basically doing is it's saying, it's giving you this access to this giant repository, and all you have to do is say, okay, let me look through my code, lines 10 to 20, they look kind of wrong, maybe I could be susceptible to a DOS attack. Let's go to SumGrep, go to DOS under JavaScript, and implement this rule. But if I'm a baby developer like me, I don't really know as much as anyone in this room, I'm not going to be able to recognize that DOS attack because I'm a baby developer. And so SumGrep is kind of that resource that isn't being utilized in the right way, and it's static. So what I wanted to do is using GPT. So this is the OpenAI playground. So it's kind of where you can customize GPT to a larger extent. So on that side, you can see that's kind of what GPT looks like for mostly everyone. You have your output, you have your input. But on this side, you can actually customize what you want GPT to do. So what I did is under the instructions tab, I fed it what a SumGrep rule looks like, and I fed it how to analyze a SumGrep rule. I fed it the link to the repository. I fed it as much information as I could. So in a way, I guess you could say I was training it, but not really. I was more so teaching it. And with all this information that I provided it, it was actually generating rules for me. And it was generating rules mirroring SumGrep, but what's cool is it was generating rules that had a lot more nuance in comparison to SumGrep. So when SumGrep would give me any form of output, I'll show later on in the slides, it would have one vulnerability per output that it would give me. It would never, ever really go into the nuance of any issue, and that's why, like, I'm sure at least half of you could raise your hand and say you've never heard of SumGrep before, because it's not really going into the nuance. And so with that shot prompting, what I was able to do is obviously the 3-shot prompt was giving me the most nuanced YAML rules. And when I actually go on to compare, how GPT was really presenting such a more nuanced rule that I could honestly say that it was one-upping SumGrep. And so with this software, I was actually able to write a shell script that kind of connects this and an array of more steps that I will go into. And I actually was able to purchase a domain, and I have a domain now called CryptoML. So this is my new product that I will be working on over the summer. And basically, my first step was actually working with GPT, but then I actually wrote a small shell script. This is just the base code for it. So it's a 6-step process. And my first step is just going through, and it's evaluating for syntax errors inside my whatever input I give it. And always the input is a piece of vulnerable code. For the entire experiment, I went through this repository called WebGoat, and it just had a lot of bad code in there, and it also had commented in what was wrong with it. So I knew when I was running it through SumGrep what to look for. But for my software, what I did is the first step was just a syntax error check, and the second step was actually going through a giant list of CWEs. So CWEs are just a large classification of different pieces of vulnerable code. And so when you see here, this is just a snippet of that list of vulnerable code that I kind of compiled with a lot of my mentors. So as you can see, this is just one snippet of this list. And CWE 787, for example, that I believe is a SQL injection. There are 39,343 instances that are all unique and different to having a SQL injection in your code. So what SumGrep is failing to do is it's giving a very generalized dictionary definition for a rule. In a sense that if I thought I had a DOS attack and I need the DOS rule, I'm going to be given that one rule that SumGrep has, and it's going to be expected to fix the DOS attack in any scenario. But the way I make a mistake isn't the way you make a mistake. It's not the way anyone else makes a mistake. Code is different for every single developer. And so that SumGrep rule might pick up on my issue, but if you make that same issue in a totally different way, it might not even pick up on it because it's structured in a certain way. So what these CWEs are providing my software is it's providing context, and it's providing 39,000 instances of this context. So that step 2 of my shell script is actually going through and iterating through every single CWE that is on this list. And how I got this list was just a simple Python script. But I went through, and iterated through every single instance of found vulnerabilities. So let's say it would say, okay, CWE 343, it was found. Now let me go through every single one of these instances. Okay, maybe it met instance number 200. Oh, but instance number 200 has this vulnerability too. Let me go check. And it was a very complicated, long process of iterating through these examples, but then when you compare the output, it really, really pays off. So step 3 was actually calling GPT for the first time, and it was evaluating the rules that applied, and it was evaluating and creating a YAML file. And this is where the cool part comes in. So step 4 is just going through and doing a little validation through SemGrep to make sure the YAML file is valid by syntax. But step 5 was something that I never actually asked for ever, and this is probably the coolest part of my project. So in the prompt that I was feeding GPT, at any point in time, all I was saying, here's some code, detect any vulnerabilities, here's some fixed code for reference. I never asked it to recode my project. I never asked it to debug my project. But that's the beauty of machine learning. It kind of knew what I was looking for within maybe my 4th or 5th trial, and it started giving me a line-by-line filtration of which specific lines were wrong. And then as I continued with my trials, it started giving me a little paragraph explanation of why they said these lines were wrong. And it's like, for example, like this user made this mistake, and this is wrong because this is why you shouldn't do this, here's how to fix it. And then by later, like towards the end trials, it was giving that paragraph, it was giving me a line filtration of what's wrong, and then it was debugging my code for me, and then explaining what it did to debug, and then it was fixing the code for me. So as a developer, this is a dream. You run this program, you go to Chick-fil-A, you come home, and your stuff's good. So I think it's pretty cool, and I wasn't expecting this to happen at all. I never asked it to rectify the code, and that's what step 5 and 6 are doing. It's just giving me a display and actually rectifying the code for me. And step 4 was just a simple validation, because the YAML file is still something that's pertinent to the output. Like, I'm sure like some people are just going to skip over that rule and go straight to the end. But when you look at the YAML file too, it's giving you a learning experience in the sense like you made this mistake and you filter through this YAML file, and now you kind of know how to fix your mistake, because a YAML file is so easy to filter through. There are other files out there, like there's XML files, there's JSON files, and they're cool. They're way more nuanced files. But the thing is, they don't dumb down what you need the way a YAML file does. And that's why I loved the fact that it was able to create valid YAML files. And when you actually go through the output now, here's the comparison. So on this side, we have what SemGrep was able to do from the beginning. So I fed it a piece of code, and it gave me a severity warning, meaning that, okay, there's this specific vulnerability. For example here, it was unsafe concatenation, and it's just a warning. So as a developer, I'm going to say, oh, okay, it's a warning. I'll come back to it later. Like, a warning doesn't really make you want to change something the way an error would, which is exactly what GPT did. For the exact same issue, unsafe concatenation, it gave the severity as an error. And it also found me 3 new vulnerabilities. And why? It was because it was going through those CWEs, and it was finding so much more context. So this is just the step 2, where it's going through and filtering through rules and finding vulnerabilities that you need to keep an eye on. But as you can see, there are 4 vulnerabilities on the GPT side versus only 1 on the SemGrep side. And this is kind of what I was talking about earlier. So this is a snippet of an output from GPT using Crypto. And there are 5 CWEs that were identified, and it gives you a little bit of a snippet sentence of what exactly was wrong. So for example, CWE 943, improper neutralization of special elements using the SQL command, SQL injection. Okay, but then again, in CWE 942, which is the 3rd one down the list, which is the CWE right before it. So it is so similar. It is also an SQL injection. It's also an improper neutralization of special elements in the SQL command. But as you can see up there, it's an RDBMS SPE specific. I don't know. These don't make sense to me. But the issue is that 943 and 942, they're so close to each other that if you run this through SemGrep, it would just say SQL injection, not give you any more context. But running it through a CWE is giving you so much more context. And even as a developer, like half of these rules don't make sense to me. Half of these CWEs don't make sense to me. You just saw that. But they don't need to make sense to me, because with my software, it's fixing and teaching it for me. Because down here, you can see this, like this is that paragraph I was explaining, that it's actually teaching me and telling me what I did wrong and why it's wrong. So the detected SQL statement that is tainted by a rec object, this could lead to an SQL injection if the variable is user-controlled and not properly sanitized. In order to prevent SQL injections, it is recommended to use parametrized queries or prepared statements. And then it gives me that line where this specific paragraph was talking about, line 17, that you should have had a parametrized query. And then it even baby feeds you a little bit and gives you where the ending semicolon is, and I thought that was really cute. But you can see that how much more nuanced you can really get output from any tool out there, SemGret, Plylint, Flake8, anything, because machine learning and artificial intelligence knows so much more than you. And like in the previous talk, we were talking about that, like any LLM, it's not always accurate. Sometimes it's going to give you BS, and that's AI. It's learning with us. But if you keep AI in your own hands, for example, what I did with the prompt engineering, you can really get it to what you want it to do. Versus when you, like for example, when you go on OpenAI Playground, when I fed it all of that context. I fed it a whole repository. I fed it how to read a YAML file. I fed it what a YAML file is. I fed it how to read a SemGret rule. If you teach it things, it is going to keep that into account. It's not like talking to a kindergartner where you have to say red is red 10 times until they understand. It's going to understand you the first time and is going to implement things for you at a much faster rate and get you the results you want. And yeah, okay, it took me 10 trials, but after those 10 trials, this was consistently getting better and consistently finding more and more CWEs. This is from like trial 6 or 7. As you continue on, there are more screenshots that I have with CWE lists that take up a whole page. It gets more and more nuanced as you continue. And so I actually have a little bit of a video of the compiler through Crypto running. So this is step 1 happening with the syntax error check. There was no syntax errors found. So then step 2 is going to run. It's going to go through code.js, which is the inputted file, look for applicable CWEs. Then it's going to call GPT. It found 3 CWEs for this particular one. It's addressing them, and then step 3. So there's the ChatGPT response, and then it gives you the little paragraph for explaining the rule. Step 4 happens. Here's the line-by-line filtration and the paragraph on top explaining what and why. And then this is step 5 with the new filtered rectified code. And then evaluation complete, and there's a little explanation and notes at the end. So what this software is really providing you is not only a YAML file, which was the initial intent, it's also giving you a learning experience. It's doing a lot of your job for you. And even if you don't use the rectified code that GPT wrote for you, that's fine. Use it as an example, because maybe that's not the style you code in, who knows. But it's there, and it's giving you information that you could use in any given instance. And I think that's what's really important to take from this. And so a couple limitations that this project had is that this really only focused on JavaScript. So a big part of when I was really structuring this project is that I wanted to understand what I could do and what I couldn't do at the age of 17. And I was really comfortable with JavaScript, so I stuck with vulnerabilities that pertain to JavaScript. I wasn't looking into things that pertain to Ruby or C++. I don't know those languages. And another thing is when you look into Java or you look into C++, when you try and compile languages like that, you have to go and you have to learn assembly languages. And with what I knew and what my mentors were able to help me with in the 6 months time that I had to really initialize this project, I didn't have time to go through and learn what an assembly language was. I didn't have time to compile Java. I didn't have time to compile C++. So in the future, like over the summer and for next year, because I still have 1 more year of high school left, I'd like to really stray away from just JavaScript and make this a more comprehensive software, because if this can find something that's more than just JavaScript, because JavaScript is a language that's used, yeah, okay, in web applications, but if you really look into languages that have a lot more pertinence, like C++, this software could really help developers at a much larger scale. And the second thing that I was actually told by a judge at ISEF was, Crypto isn't really finding anything new. It's taking resources that I've dumped into it and giving me a dynamic, comprehensive piece of output. But what if there are like vulnerabilities that exist or that come up that aren't exactly identified in a sense? Like, what if it's a new vulnerability? Because as developers, when we make mistakes, hackers are going to try and one-up that mistake and hack into it, and it becomes a cat and, like what's the word? Cat and mouse chase. Because hackers are always getting better, and developers are always going to be one step behind, because the hacker is always going to find something new, and the developer is going to have to play defense. But Crypto isn't really going through and finding these novel rules. All it's doing is it's taking a lot of context and giving you a dynamic rule. So in the future, I definitely would like to expand this out of just pulling from a repository and pulling from knowledge that SEMGREP already has, but really make this something that's filtering and fundamentally going through line by line pieces of code and looking for things that could be a new vulnerability. Make this, instead of playing defense, we could for once play offense with something using generative artificial intelligence. So just some ending notes. I know that I did not go 40 minutes, but I guess questions can take that up. Some implications of this. Crypto's main purpose of this entire project was to add to what SEMGREP has. At no mean did I want to demean what SEMGREP has, but it was enhancing what SEMGREP was doing at a way, way larger scale. And instead of having to now sit there and manually, line by line, half asleep on 3 things of coffee, go through your code before you compile or before you commit your code, you can actually just run it through, and as I said earlier, go get Chick-fil-A and come back, and your code is debugged and it's ready for you to filter through one last time before you commit it. It's giving you way, way less labor time, and it's cutting down everything it's cutting down your input into the project a lot, and it's going through and doing things that aren't the fun part for you. So a little bit of a special thanks. So my first special thanks, he's in the room with me in the back. That's my dad. He was a big help in this entire project. And then these are my 2 mentors. They're both from Orlando, from Stetson University, Dr. Daniel Plant and Dr. Joshua Eckroth. They both really, really helped me through this project. They introduced me to SEMGREP. They introduced me to all the different softwares that I kind of came across this entire project. And thank you. So I guess I'll eat up the rest of my time with questions.
Okay, thank you, Meghna. That was fantastic. I was just curious. So, like, ChatGPT has this notion of a context window, right? So, like, you can really only ask it questions with a certain amount of data. Do you find that that is a limitation of any kind, sort of versus SEMGREP? Like, do you have to bust up the code base into smaller chunks, or was that not an issue in your research?
It's definitely, it is a drawback in a sense, because with SEMGREP I didn't have to feed it that data, but at some point someone was feeding the data. So at the end of the day, the process is the same, because SEMGREP was hand created, it was hand compiling all that data. For me, since ChatGPT was working from scratch, I had to feed it that data. But at the end of the day, it's not really a roadblock, because you can't expect it to do for machine learning to do something without actually giving it the teaching to learn. So I don't think it was it was not a drawback, it was just a time issue.
Okay, cool. If you have questions, here's what I want to try to do. We need to get the questions into the microphone so they can be recorded. If you can come up to the front and use the microphone to ask your question, that will save me trying to summarize your question. If you don't want to come up front, just shout it out and I will attempt to summarize for the recording. Anybody have any questions for Meghna? Yes, please. Now we gotta wait for everybody to like walk through rows of people.
So first off, incredible.
Thank you.
Amazing.
Thank you.
Glad you were able to do this. Just thinking of it from a counter perspective, as you're working with SEMGREP and these tools to develop basically a tool that will improve code, what you're doing is you're teaching and training and learning within these models to develop, hey, here are the types of vulnerabilities that we have, here's what you might do to fix those. Have you considered the offensive perspective of what are you going to do when adversaries now start investigating your work and using your work against you in the development of, oh, this is how this model recommends that we make this change, resolves this vulnerability. This is how I can get around that now, right? And so it just becomes, like you said, the cat and mouse, but how are you building that into your solution to prevent that from happening?
I've gotten this question before, and I keep saying I don't know. But I think one big thing is that's a big ethics question, because there's always softwares out there that are trying to do something good, and there's always going to be someone who's trying to work around it. And I think that's just something we're gonna have to deal with, in a sense. Like, you could use this software in bad ways too. Like, if hackers purchase this and then they're trying to see, okay, if I run this code, here's what they find, let me target these things, without them rectifying it first. And that's just something that I guess with time, with machine learning, if I can implement this to maybe have kind of like what you said, like an adverse attack almost, like have it give me another snippet saying, if a hacker were to look at this, here's what possibly could happen. Because there are tools out there, like I know Bandit, which was one of the static analysis tools that I mentioned earlier. They have a couple things where they look into like what this looks like from an outside perspective. So maybe if I could teach it some research like that, it could give you a developer kind of a warning, in a sense, of what could possibly happen if you do it this way, and here's another way that you could work around it. But I guess implementing machine learning at a higher level could help with that, but at this point, I really not sure.
Fair enough.
Yeah.
Thank you.
Mm-hmm.
Okay, Rosie Hall, did you have a question? Okay. Yes, please.
Yeah, 17-year-old, very impressive.
Thank you.
What made you choose SemGrep as opposed to, like, say, Sneak or Aikido or, I don't know, Veracode?
I looked up 4, and those were the ones that I kind of compared between. It was SemGrep, Pylint, Flakegate, and Bandit. Those are the ones that I looked between. I think the biggest thing that is I was really, really in love with the way SemGrep wrote their YAML files, because I never knew what a YAML file was before I did my research, and the way that it was very easy to filter through was something that I appreciated. And so I liked the simplicity, and I also liked, like, for example, Pylint and Flakegate, they're linting tools, and a lot of these other ones are linting tools, and so they're not really going deep into kind of what's really wrong with whatever input you're giving. And so I really like the fact that SemGrep was efficient, it was easy. And then the graph that I had earlier, it showed that SemGrep's running time is so much lower than all of them. So my biggest thing was I was chasing efficiency, because this still was a science fair project to me at that point, and I wanted it to be fast and I wanted it to be reliable. And I liked the fact that SemGrep had a static repository that I could look into. It had very easy to filter YAML files, and its runtime was very, very low.
And again, you prefer the SAST approach as opposed to dynamic?
Yes.
All right. Any reason why?
I guess chasing efficiency, that's like my biggest point.
Any other questions? Yes.
Thanks very much for sharing your research with us. One of the things I'm always paranoid about with anything LLM is hallucinations. Did you hit any hallucinations, like new CVEs that actually don't exist in your research?
Yeah, so that was a big part of when I was going through 0-shot, 1-shot, 2-shot. There were so many times, like especially with my 1-shot, 0-shot, sometimes 2-shot prompts, I was getting a YAML file that's fighting something that was not even a real issue. Like there would be parts of the YAML, like you know how YAML has like the definitions and classifications area, they were blank, but they were still fighting something. Like the YAML file had no cohesiveness to it, and I think that was a big part of why I kept increasing the shots until I got cohesive actual real YAML file rules. So that's a big part of shot prompting and prompt engineering. When you're working with LLMs, you have to give it the optimized input, because you can't blame a LLM for giving you bad results when you're not really giving it enough to work with. So I think the biggest thing with hallucinations is in order to mitigate them, you have to give as much context as possible, because it is still, you have to teach it in order for it to learn. Yeah.
Adrian, do you have any questions for our speaker? He says no. Okay, anybody else? Yes.
Fantastic.
Thank you.
let's pretend we're like a year from now, you're grossly successful in making everything you want, you've got your business stood up. Like, what does the delivery model look like? Is this on developer machines? Is this in CI/CD workflows?
Developer machines.
Okay.
I definitely do want to keep this. So a big problem or a big question that I was asked during one of my competitions was, do you want this to be public or do you want this to be almost private in a sense? Because let's say like you're compiling your code and this is going through GPT, but then GPT keeps the code that you've inputted in a database. Then what? Then if this is something that you didn't want your code to be out there for GPT to ever reference, how is this going to work? So I definitely do want to keep this developer side, make it a command line tool, something that never really leaves your computer, never really leaves your area. And the only thing that GPT is doing is calling an API, running its results and feeding it back to you. So definitely a developer tool, most likely a command line tool that can be implemented by solely developers.
Like everybody else said, very impressed.
Thank you.
So GPT has had some kind of public oopsies lately. What is your plan if they disappeared tomorrow?
That's a good question. Well, I mean, there are other models out there. I think the reason why I went with GPT is because it's that home brand name that everyone knows, and it has the most context because everyone's using it so much. But there is Gemini, there's Claude, there's a lot of other models out there, and yeah, maybe GPT might disappear tomorrow, but AI and like LLMs are not disappearing tomorrow. They're never going to disappear. So in that case, it would just be training a new model and training a new set, because they're all kind of doing the same thing and just in different ways. And honestly, if I use something like Claude, which is a much more niche LLM, it might even provide better results. I never really went through other LLMs. So definitely going through, I hope GPT doesn't disappear tomorrow, but if it did, there would be other options, I think.
Any other questions for our speaker? Okay, seeing none, let's thank Meghna for an excellent talk.